Hi everybody, this is Miss McClellan here to go over IM2 Checkpoint 2.3, the practice version. Let's start with number 1. We will select the appropriate justification for the word bank below for each missing justification in the flowchart. Note that some words may be used more than once and not all words will be used. Okay, so we're trying to prove that line segment AC is congruent to line segment DC. So that's going to be the ultimate conclusion of our proof. And I know that I'll be using CPC/TC to do this. So congruent triangles gives us congruent parts. CP, CT, C, congruent triangles, C, P, C, CTC, PC. Anyway, congruent triangles implies congruent parts. Okay, so in order to use CPC/TC, and that should have been CPC/TC, but you can say this if it makes more sense to you. We need to prove that the triangles are congruent, and that's what this first part of the proof is doing for us. We have a congruent statement ABC. Triangle ABC is congruent to triangle DEC. Let's see how we know. Okay, I see I have a vertical angle here. So that's an angle. And the right angles are congruent. So I've got two angles and a side. Angle, angle, side. And the sequence is angle, angle, side. The side is not between the angles, it's next to them. So angle, angle, side congruence is how I know, and that is one of my options. That means I'm going to have to describe the side in each angle. So that's what I have here. Angle, angle, side. How do I know that BC is congruent to CE? Well, that's given by the tick marks. And how do I know that triangle ACB is congruent to triangle DCE? Well, those are vertical angles, and vertical angles are congruent. So vertical is my justification. And that's one of them too. And how do I know that triangle D is congruent to triangle A? Well, that's given by the angle markings. And behold, we have side, angle, angle, which is the same as angle, angle, side, congruence. This is a complete proof now. Let's continue. Okay, this one's harder because I have to make my own design, but the structure should end the same. I'm trying to prove that these angles are congruent, and I'm going to use CPC/TC for that. So I'm going to end with the fact that angle A is congruent to angle C, and I'm going to use congruent triangles imply congruent parts. Or if you prefer, CPC/TC. Corresponding parts of congruent triangles are congruent. That's what it stands for. Ha. Okay. So in order to use CPC/TC, we have to prove that triangles are congruent. So the triangles I see here are triangles A, B, D, and I want to prove that that is congruent to triangle. Okay, let's see which angles I have to talk about. I'll go triangle A corresponds to C, So C, ABD corresponds to BDC. So I'll go D next, and then the last letter is B. How am I going to do this? I see that I have an overlapping side, so I know I have a side. And I see that I have these parallel lines. Okay, the parallel lines DC and AB allow me to use alternate interior angles right here. So I see that I have angles as well. And then we have two sets of parallel lines, which is nice. These parallel lines allow me to say that these angles are congruent. So I'm going to have angle, side, angle. Okay, so now let me do my angle, side, angle. Angle, side, angle. And I didn't make these boxes different sizes on purpose. That's just how the drawing went. Okay, let's start with angle ADB. Angle ADB is congruent to angle CBD. And that is by alternate interior angles, which I'll have to add another justification for, because anytime I use alternate interior angles, I'm depending on parallel lines. And I do have those parallel lines. I have that AD is parallel to BC, and I'm being really careful to make sure I'm talking about the correct parallel lines, because these angles that I just talked about depend on the parallel lines that they touch, those being AD, BC. And the way I know those are parallel, it's given by the arrow markings. If you just wrote given in your proof, that would be okay. Okay, now the side. DB is congruent to DB, and that is reflexive. Recall that reflexive just means same side. I'm not going to write that because I don't want you to think it's part of the solution. So hopefully if you're watching the video, you have your sound on. Okay, last angle pair, I'm going to do angle CDB is congruent to angle ABD. And that is also by alternate interior angles. And since I'm using alternate interior angles, I have to make a statement about parallel lines. For this pair of angles, I will use this pair of parallel lines because the alternate interior angle must touch the parallel lines. So I have DC is parallel to AB, and that is again given by the arrow markings. And then here we have an uninterrupted logical chain. I've got the parallel lines that allow me to make the claims about my angles. I've got the side, which is between the angles. But angle, side, angle congruence, therefore allows me to claim that the triangles are congruent. Congruent triangles have congruent corresponding parts. Therefore, I can say that angle A is indeed congruent to angle C. Next problem. Now I'm moving on to similar triangles. And we're going to try to find the error in this proof. Okay, let's see. So they're trying to use ASS similarity. ASS does not work for congruence. And it does not work for similarity. So that is definitely an error. Let's see if I can find another one. I'm still looking. Angle Q is NRM. That's true. But yes, it appears that the error is in the congruence statement. The error is they wrote ASS similarity. Notice, everybody, that the symbol for similarity is not the same as the symbol for congruence. This is not this. Similarity and congruence are not exactly the same thing. Okay, so the error is that they wrote ASS, which is not a similarity criteria. So I know that that's their error. But other than that, their proof actually looks pretty good. So they could have, we want to correct the error on the diagram. We could have written side, angle, side, similarity, which is a similarity criteria. So I know because they wrote the letters in the wrong order. Okay, we continue. Prove the triangles are similar. Okie dokie. Well, I see that we have parallel lines, and that allows me to use alternate interior angles, so I'll use these two. Okay, I think we're going to be using angle. So I'm going to start at the end, which is what I usually do, and say that triangle UPV is similar to triangle QPR. Careful with your congruence. I put Q corresponding to U because I see that they are alternate interior and therefore congruent angles. Let's see. So triangle UPV is similar to triangle QPR, and I'm going to be using angle similarity as my theorem. Since I'm using angle similarity, my evidence column has to have two pieces, one piece for each angle. I know that angle UPV is congruent. Remember to keep these symbols clear. This one means congruent. This one means similar. Okay. Angle UPV is congruent to angle RPQ. And those are, I know because those are vertical angles. For my other angle that I'm doing, I'm going to say that angle U is congruent to angle Q. I don't need three letters this time because it is not ambiguous. If I say Q, there's no other angle I could be talking about. I can't call the one above P because I could be talking about two angles. So I need three letters for the vertical. Okay, back to this one. I know that angle U is congruent to angle Q because they are alternate interior angles. But whenever I say alternate interior angles, I need to justify that by saying what my parallel lines are. So I have UV is parallel to RQ, and that is given by angle, sorry, not by angle, arrow markings. Okay, that's a complete proof. And that was the last problem. So all I have left to say is thanks so much for your time. Do be careful because there will be more questions on your checkpoint not represented here. You need to do your homework to study for those. Hope you have a great day. I hope this was helpful. Bye.